Hi, and welcome to the video on experimental probability. By the end of this video, you should be able to find experimental probability and know the difference between it and theoretical probability. So let's take a look. You see, some events you won't be able to work out the expected probability until you actually run an experiment. A good example of this are drug trials. When testing a new drug, the only way to work out the probability if it will be effective is to run a trial and see how many people it positively affects. A simplified model may be that 1,000 people are given this drug to test and 900 are cured. This may mean that the drug has a 900 out of 1,000 chance of working, or 9 out of 10. When only a few trials are conducted, experimental probability and theoretical probability may be very different. For example, if you flip a coin 10 times, you'd expect tails 5 out of the 10 times. But it's possible to get very different answers to this. However, if you were to flip the coin 100 times or even 1,000,000 times, you would start to see that the experimental probability gets closer and closer to the expected theoretical probability. This is why trials are conducted. Just like all probabilities, experimental probability can be written as a fraction, decimal, or percentage. Each has their own benefits. For example, if something happens 4 out of 9 times, you can see that the probability is going to be 4/9. This may not be so apparent if you wanted to try and write it as a decimal. However, if I'm comparing two different probabilities, it might be easier to write them as decimals rather than fractions. Here it's easier to see that 0.4 happens more than 0.3. The same benefits are had with percentages. It's easier to see that something that happens 40% of the time is going to have a higher chance of happening than something that has a 30% chance of the time. So let's take a look at an example. It's quite wordy, so let's break it down. When playing with a spinner with 4 numbers on it, the following results were recorded, and we have there 10 numbers. We're going to try and find the probability, the experimental probability, of getting a 3. Well, the probability of getting a 3 is going to be a fraction, and that fraction is going to have a numerator that has the number of 3's at the top and the number of numbers down the bottom. So if I count up the 3's, there are 4 of them, and the total number of numbers there is 10. That's the size of the sample space. So the probability of getting a 3 is 4 out of 10, or simplifies to 2 out of 5. This means that if you were to use this spinner and it was consistent, then you would expect every 5 spins you would get 2 3's. Let's take a look at the probability of getting an even number. Again, it's easier to write this as a fraction, so I need to count up how many even numbers I have. The 2 4's and a 2 are all even. This means I have 3 chances out of a possible 10. Now, based on this experiment, how many times would you expect to get a 3 if you spun it 1,000 times? Well, we know that the probability of getting a 3 is 4 out of 10. And we want to know the probability of getting it if we did it 1,000 times. Well, as you can see, we did 100 more experiments. So we would expect to get 100 more 3's. This means that our probability of getting a 3 would be 400 out of 1,000, and you would expect to get 400 3's. So what should you write? Well, you don't have to write all those examples. You're going to have plenty of opportunities to have some in your book. A heading of experimental probability is good, as well as what it is. And then having that little formula there, that probability is a fraction, which is the number of favorable trials over the total number of trials. And that's it. Hopefully now you know how to find experimental probability. It's very similar to theoretical, but now that you know the difference between the two, that experimental probability is what you get when you conduct the experiment, and theoretical probability is what you would expect to get. Good luck.